u cos theta, other will be u sin theta. That u sin theta will determine the plane of circle. We will bring all that radius, everything. This will become radius of helical path. This is called as a pitch. So what is the radius of helical path? And this is called like a axis of helix. So this, what is the path? You have to call this as helical path. Now, what is the motion of what is radius of helix? Radius of helix depends upon the component which is perpendicular to the magnetic field. So in the books, they are given this as u perpendicular, u parallel, justified. This. So now the radius of helix is given by r equal to mu sin theta by qb. Then at t equals 0, it is here. After what time it will complete one revolution? So shall we go for the tracing of charge particle is going to move? This will become one time period of revolution. So after every one time period of revolution, it will come and touch the x-axis. Means like we are not understanding. Okay, because you'll never understand. It's a three-dimensional diagram. So what you should do, convert that into a plane diagram. In which plane it is moving in circular path? In y minus z plane. Plus or minus yz plane. So you have to convert this into a plane diagram of like this. Now the path will be so this is the initial u sin theta. I'll explain everything. Here is this one, and the b bar will be directed out of the plane. This will be the radius, capital R. Students, nobody is interested to draw diagram. They want to fight here only. That's why you are going to struggle. Why you are unable to solve problem? Why you are unable to think? Because you yourself don't want to think. Yourself inverting problem. Just draw. Whenever 3D diagram comes, convert the problem into two-dimensional. It's very easy to analyze. Now let's discuss. Let's not bother u cos theta. Let's bother about only u sin theta. Then I projected with a velocity u sin theta in a uniform magnetic field. What will happen to the particle? It's going to describe a circular path. What is the radius of circular path? Mu sin theta by qb. Okay, leave it. This one. Then let's forget there is no u sin theta. Only u cos theta is there. Because of u cos theta, what should happen to charge particle? This u cos theta is parallel to magnetic field. This u cos theta is parallel to magnetic field. So therefore, what type of motion due to u cos theta? Just uniform velocity motion. Now combines for this circular motion and the uniform velocity motion. Then how the path is going to be helical. Then whenever helical comes, what is the plane of helix? Plane of helix is what, like plus or minus y minus z plane. This is very important. What is the axis of helix? This is similar to spring. How the spring will be there, no coil, similar to that. The particle, what is this? Helical path of a charged particle. Helical path of a particle. This is the external field. External magnetic field. We have applied it, uniform magnetic field. Axis of helix is, what is the axis of helix will be? X-axis only, because from there I projected axis of helix is here, x-axis. So whenever helical path comes, you should identify these two things. What is the plane of helix? What is the axis of helix? Plane of helix means the plane in which it will be moving in a circular path. And what is the axis of helix? This is very important. Okay, now, so like this is going to move in helical path. So now let's come for this one. What do you mean by like a time period of revolution? Time taken to complete one revolution. So it will start here. After one revolution, it will come and touch the x-axis. But by the time it has covered some displacement, it has moved some displacement along. Similarly, again, it will start. It will not touch x-axis. It will be there in the y minus z plane. So where is this point? This point will be here. Hope coordinate geometry, your coordinate geometry is very, very essential. T equal to 0, it will be here. T equal to t by 2, it will touch the negative z axis. Then t by 2 to t, it will come and meet the x-axis. Here it will be. So it will be like this. Now here it is not touching x-axis. It will be there on the z coordinate. Of course, it will have x coordinate here. Y coordinate will be 0 and z coordinate will be non-zero. Now it will come and touch the x-axis. Then what is the value of z? Z will be 0 now. Y will be 0. Only x coordinate will be there. So the points, I'll just indicate like this. These are the things at which it will touch the x-axis. Hope everyone, so it will be like this. T equal to 0. I'll write it at least here. Here it will be t equal to t by 2. So now what about what is the instant of time here? T by 2. This will be t, capital T. So here nearby it, I'll write it here. This will be t. This will be 2t. And what about this? This will become t by 2. This will be 3t by 2. This will be 5t by 2. This will be 3t. Then how much of what is this pitch? The distance between this one. This is the distance between points where the particle will touch the x-axis. This is called like a pitch. So how to calculate that one? The pitch is equal to given by u cos theta into 2t minus t. What is the time period? T equal to 2 pi m by qb. So this will become so 2 pi mu cos theta by bq or qb, anything. This is called a pitch of helical path. Okay, so these are the we have studied this one. So it's a more three-dimensional. So a student must have a better picture. You have to always come for a diagrams of like this. These two diagrams should be there. 3D diagram and in which plane they're moving in circular path. That should be there. And now I'll ask you a question like, if this is a coordinate origin, this is origin, no? I want the position vector of a particle. Here, directly I'll draw an arrow. I want this r bar. Can we find out? And I want also the velocity vector also at any time t. In this problem, we have to find out the velocity vector and position vector of a particle. What is the best method? Split up this problem into motion of a particle along x-axis and motion of a particle in yz plane. Then the take vector sum, you're going to get the required answer. So let's do that one. So let's find out the position vector and velocity vector of a charged particle moving in this given region. So how to calculate the position vector? I will directly take help of the yesterday's discussion what we made. How to calculate the position of a particle at any time t. After t equals 0 here, after some time t, the particle will be available here. This velocity, what I do is like I'll call it as vyz plane or keep it here, no problem. U sine theta. So here it will make an angle. Now what is this? This will become y coordinate. This distance will become radius r. This will become y. So y comma minus z. This distance will be minus z, no? Can we define all the quantities? So this will be theta. It has rotated. Okay, this is phi. I'll write it. Theta we took it, no angle of projection. This is a phi. I think we can define all the quantities. Coordinates of this point P. P I use for pitch, no. So let me use the position vector at point A. Can we define what is first Y? I take help of that diagram. So let me push this diagram below related to this. I'll write down all the equation. Or this may not be that important. I will push it here. Now, looking at this, we'll write the equation. First, I want R bar. R bar should be equal to xi cap plus yj cap minus zk cap. Because it can never have positive z coordinate. Am I right? The charge particle can never come along native z axis. So this is just right. What is x? I should write u cos theta into t, the x displacement, because what is the component of velocity along x axis? U cos theta into t. So therefore, this will become still more. We'll push it here. And then what about y coordinate? First, we'll define some triangle here. Sine phi is equal to y by r. So y equal to r sine phi. What is phi? I should call omega. We'll agree this. And what is omega? bq by m. So this everything will become sine omega t. What is small r? I should write here. Small r should be equal to mu sine theta by bq, not u, because what component of velocity will determine the radius of circular path. This is capital R. We made it. Yeah, I'll change symbol. It is capital R. Radius of helical path already we have defined, no, mu sine theta by bq. So that only I'm writing it. Then further, this omega, what you can write, bq by m. Okay, this is what y coordinate we got it. What about the z coordinate? R minus r cos phi. That coordinate should be. This total distance is r, capital R. What is this distance? Will be r cos phi. This is r sine phi. This is r cos phi. I want this distance because this is that coordinate. No? I'll remove this minus z. It will be much easier for you. So this distance is r cos phi. This is r sine phi. What about this distance? The remaining this one, r minus r cos phi. That is what the z coordinate. So this will become r 1 minus cos phi. What is r is equal to? Mu sine theta by bq. What about phi? Phi will be omega t. I think first we should have all this general setup. Omega is bq by m. Now you substitute all those things. So now we have a suitable equation. We'll write x also here. We'll determine the x coordinate, the component of velocity along x axis, u cos theta into t. Now we'll write it. Now let's write, dump all those things. That will be our equation. Y will be mu sine theta by bq. If you want q by m, you can write it as alpha, specific charge, j cap, and this will be mu sine theta by bq. Okay, this one. So like this, we go the position vector. So sir, can you show that R bar in the diagram? Where is the R bar in the diagram? So some, I think I'm going to mess up the diagram. Let's, this R bar. Position vector, position of particle at any time t. This will be, I'll go for one more diagram. Completed, all of you. So helical path is nothing big. Circular path in one plane and uniform velocity motion along the axis of parallel to axis of helix. That is enough. Like this, I put t equal to any time t, you can get the position vector of the particle. So let me show that what is that position vector, how it will be directed. The charged particle is going. Let's looking at this diagram, we'll write the equation. This I'll remove this, may not be needed all this one. I'll write down the possible now. So this angle, how much it can be? It will be equal to, this is phi. Then this angle must be phi, not theta, phi it is. Can we resolve this velocity now? V bar equal to Vx bar plus Vy bar plus Vz bar. What is Vx bar equal to? This should be equal to U cos theta I cap. Now what about Vy? U sin theta cos phi j cap. What about Vz? U sin theta sin phi k cap. At any time t this is. So what is like a phi? Phi is defined like this here. Further, what is omega? Omega is bq by m. Now you bring that omega into picture. So this will be u cos theta I cap, u sin theta cos. This will become bq t by m j cap, u sin theta sin bq t by m k cap. Now, shall we, sir, will you take this negative sign? The moment t greater than 0, the particle will have the negative z coordinate. I think justified. Okay. But sir, it can also be positive as after some time t. Based on the value of t, this quantity sign can be positive, negative. Correspondingly, it will assume that signs. Let's not bother. But t greater than 0, the particle will have negative z coordinate. So that is what we are putting here. So this is the expression for velocity of charged particle at any time t. You want the velocity at any time t, as substitute the value of t there, you will get the velocity. Substitute the value of t in the position vector, you get the position of a particle. Now, what is the conclusion? Can it move? Can it ever have negative z, positive z coordinate? Not possible, no. The particle can never have positive z coordinate. Okay, there's a one basics of the helical path. So when do this helical path will come?